Alright, welcome back guys. Today we're just going to go right into the assignments since we're all done with the content and everyone's following different revision schedules. As for what's happening when we move to past paper assignments, I'll probably get onto that next week because that's when the last assignment is. But this is quite a late video, so apologies for anyone that tried to do the assignment early and didn't get the video on it. But that's okay, we'll just get straight into the assignment. So, question 1, convex concave. So it's all just about finding f dash dash of x and setting it greater than 0 and then setting it less than 0. I skipped a lot of steps here. Again, as I say for every assignment video now, all of my work, don't treat my work like it's an exam question. Treat my work as if I'm just doing the question to find the answer, unless it's maybe like a proof question. So yeah, you just do this, and yeah, these are the intervals because you have to use these interval notation. Here, same thing, do the same thing here. Then part C, same thing, just make sure you're in the range. This is always, I think on the one of either D or F is wrong on the mark scheme, or on like I don't know if they've changed it because I did the assignment like the day it was created, but and that's the same with a lot of the mark scheme. Like the mark schemes do change a lot. They have some wrong stuff in the mark scheme, so it does change a little bit. So this one is always convex because it's a positive quadratic, and then this one is always concave because ln x is just a concave function always. You can obviously prove that. And then for part E, just same thing. Right, question 2. They've been loving the parametric integration recently. I don't know why, in class and in assignments. But anyway, you do y dx dt. That's how you do these questions. You can do it with substitution. Say you're going from y dx to like dt, but the formula that you can remember is it's the integral from the two t limits of y times dx dt. You do find your values of a. This is just setting it equal to 4, or setting the y1 equal to 4, and then finding the region. So you just do y dx dt as I said, and then you can integrate that, which will give you this answer. Question 3. Just trapezium rule, could literally just do it on your calculator. Question 4. Again, the iteration questions are quite nice because they're easy. So you can rearrange this, do your little spider diagram, and here, yeah, do the spider diagram again, and then there's your answer. So for question 5, I tried doing some fancy proof notation. All you have to do officially, all you have to do is say the function is continuous. The function will always be continuous unless like it's obvious that it isn't. Unless it's genuinely unless it's piecewise, unless the function is piecewise, as in like it's two different functions on different intervals, it will always be continuous in questions like this. And so you say the function is continuous, and there's a sign change, and therefore there's a root in this interval. Then you do Newton-Raphson over here to get your thing, and then differentiate, and then you do Newton-Raphson, and then you differentiate, and then you use Newton-Raphson again. What is this? Oh, this is a different function, right? Yeah. So yeah, you do Newton-Raphson for this function, the different function, use differentiation, and then do Newton-Raphson again. Show that the speed is constant. Well, I kind of just did both of these at once because this is what a circle actually is. If you think about what a circle is, like I said, the equation of a circle, x squared plus y squared equals 1. The only like function of x and function of y that makes sense there is sine and cos. So, but if you do the magnitude of this, it will always be the same because when you do x squared plus y squared, or the x component squared plus the y component squared, which is that, but then the sine squared bit cancels, so you just get this, which is, and then therefore velocity is 12. And also you've proved that it's a circle because it's the equation of a circle. Same thing here, don't worry about this notation, it's just a sign change stuff. What are we doing now? Show the x coordinate of P. Oh, so this is just Newton-Raphson, and then part C, you do Newton-Raphson, do it again. or sorry, you do iteration and then you do Newton-Raphson, sorry. Uh, Next, this is a very interesting integral actually. Obviously, you just do trapezium rule first, and then you state like the if it's concave or convex. You can kind of see from the diagram, and you can think of concave as a cave, which means that like then from the fact that it's a cave, you can figure out that what all like the actual rules are about it. That's kind of how I remember which one's which. And then finding the actual integral is actually interesting because you have to divide both sides by divide both sides by root x and also factorize 10 out, and then you can use ln on that, which is quite interesting because this is in the form f dash over f. This is like very hard. I don't think there's any other way to do this. This would actually be really hard integral to do. This would be a really hard integral if it came up. If there's not another way to do it that I haven't thought about. Partial fractions, simple stuff. I totally did this in my head and didn't just skip to the answers, allegedly. Part B, sorry, you do the integral and you simplify. Yeah. Question T, some more parametric integration. So first you do this proof result, then y dx dt again, and then you get this, and then you can use the thing you found earlier to separate this into just easy terms to integrate, and then there's your answer. And then another integral, so we're eating good today on the section A. Sine sec is just sec tan, which just turns into sec x. That's an easy question. Sine sec squared is just sec tan. And then substitution, this is just going to be 1 over u to the 4. Pretty simple substitution. Get your answer. Next, another sign change. And then another iteration, rearranging, blah, blah, blah. Then Newton-Raphson, blah, blah, blah. What? Why have I done this here? Oh, because this is another sign change, and then you do Newton-Raphson. This is a nice question. The maximum value of nth root of n, which is this. So this is just I've just replaced the n's with x's because it makes it easier for me to see. So this is just x to the power of 1 over x, and then you can this probably looks a little bit more familiar because if you should have done in class the derivative of x to the x is one of the questions you just randomly done, where you take the logs of both sides and then here I multiply by x and then the product rule, and then eventually you can rearrange. You get x equals e, so the answer is eth root of e. Which is pretty interesting because e just randomly comes up here. It comes up in a lot of places in maths, so not very surprised to find it here. So, points of inflection, this was really annoying. Oh yeah, this question was insane. I don't know what they were really trying to make us do here, because differentiating some of these functions twice was actually ridiculous. So this first one was fine. You just had to you have to test all these points to see like if f dash dash of x changes if it changes sign before or after the points, because you have to change that, you have to test that, which I totally did. Here this is you have to do algebraic division. I was hoping that this would just factorize, but it doesn't. Then differentiating it twice gives you this, and then you can find this is the easiest one, really. And then here, I kind of just saw that this is pretty not very horrible to differentiate, but differentiating this again would be horrible after doing quotient rule and then doing another set of product rules and quotient rules. So I kind of just cheated by just deducing that this was going to be a very big fraction with no constant term on the numerator. Therefore, it would be a very high degree polynomial on the top, which we're not expected to be able to solve. So I just deduced that x is 0 because it's not going to have a constant term. You're going to multiply out by the denominator to get like minus the big polynomial equals 0. But it's not going to have a constant term, so you can factorize x out, and that's going to give you x equals 0. I'm really not sure this would ever come. This would never come up because, firstly, it would give you a massive polynomial that you can't solve, and it would also just take ages. Anyway, I don't know why this question took me so long. It really isn't that hard. You set up your projectile stuff. and you set up simultaneous equations here. So this, you can say this is the max height, this is the this is the max height, this is the range. Find t. Remember that 2t is the range, so the time that it takes to go from the initial point to the top, that's half the time that it takes to do the entire thing. And then you can set up these equations with, this one is with s equals ut plus half at squared where a is 0, and this one is with v equals u plus at on the vertical. And then you can do root. This is kind of in the, you should recognize this from R alpha. This is how to solve this type of equation, where you divide the two equations to get rid of the u's, and to find the u, you do root one of them squared plus the other squared, and you can get your answer. This is an interesting, I think most, or we've done this in, my class has done this in class before, but might be different with you guys. Anyway, so R alpha, again, comment if you want to know how to do this method for alpha, to not have to like write all the working out, because this does give you 4 marks in the mark scheme. I've looked at many mark schemes for R alpha. It's always 3 marks, sometimes it's 4, but it's usually just to find no accuracy. It's 1 mark is for R equals the root something squared plus something squared. The other one is for alpha equals arctan of something over something, and then the last mark is for writing it in the correct form. So you don't actually have to do any of the working. So if you know a special method to find R and alpha fast, which I do, which I'm not going to explain now, but I can explain it. I can explain it if anyone asks in the comments. Then you get all the marks for it still. So yeah. Anyway, back to the model. So replace this with your R alpha thing that you found, and then so show that the max is when this is 1. Next, find the value of x. So you just set it equal to 1. Next, find the value. Oh yeah, so then now we set it equal to 1000. So I've done a little bit of rearranging here. So you set it equal to 1800 and then divide by 250. This model here, and then you get this equals 2 fit, and then they're your answers. You for these like ranges, you kind of just have to think about it. Oh my god, my voice. Anyway, nice integration stuff here. I mean, it's not very nice because when Linux in integrals is just a bit annoying because you're going to get an annoying fraction. So you find the intersection point, which is going to be 1. And then do the integral. Do your, again, I can make a video on the DI method if you want, or you can just watch the black pen red pen video on it. And then you get your answer. Oh, this question was dumb. So I think for what it meant by the identical thing is that if they have so they can be parallel to each other, but in order to be identical, they must be parallel. So it's if anyone here is going to do Tamur, that's a necessary condition for it to be parallel, for it to be identical, is that it's parallel. But the thing is, firstly, to prove that it's identical, we first have to prove that it's parallel. So, and then if we do that, if there's also a common point, then it will be identical. If it's parallel, but there's not a common point, they're not identical because they're just going to be moving at the same rate of change, but like at different points, if you kind of get what I mean. So for part A, you say that you can take a factor out, so that it will be parallel. You can take a factor out of this thing here. And then they also have a common point where you can kind of just figure it out. You can just do your value of t. You can the way you're supposed to find the common point is to just set them equal to each other and find where they intersect. But with this one, it will just give you all. It will kind of mess up because this is identical. So it will all the points intersect at once. So. But if you just pick a random point, so obviously 1, 2 is here when s is 0, and then you can just set this one equal to 1, 2, and see if there's a t value where it works, which I did here, and that's how you prove that it's identical. So for this one, they're not parallel or identical because then there's not a scalar here. But this one is parallel but not identical because they don't have a common point with each other. So they have a scalar, but they don't have a common point. All right, back to stats, unfortunately. Back to the unfortunate reality of this course. So find R, interpret the value of PMCC, cool, just positive. Always, whenever it's asking you about the PMCC, it's about like the degree of linearity. That's what the term you should use, or positive linear correlation. Always use the word linear because that's what PMCC is measuring. Do your correlation test. I've explained enough of these to explain how to do them. Then comment on the statement. This is a common. Well, it's not even common. I've never even seen this, but pretty obvious kind of thing. Expand this, and then for this you can just write these out equal to. So you write these 3 minus x next to your bracket here. I kind of shortcutted it. And then find the coefficients of x cubed, which will be these two terms here. Question 7, expand. B, expand. C, here you can, so again, you should probably write them next to each other, but I kind of just skipped that step and just kind of looked at them like this. So you have to see, find the coefficient of x, find the coefficient of x squared in terms of a and b, and then solve simultaneously, and you get the answer. Coefficient of x cubed is going to be ab squared minus b cubed, which is going to be minus 36 because we found the values. This question's not very interesting at all. So you set up your distribution, put it in your calculator, put this in your calculator, and then this is conditional probability. Like, given that they're running after 22 minutes, that they're going to run are in the next 2 minutes. That's basically what you're doing. There was, thankfully, thank God, there was only one mechanics question on this entire thing, because mechanics questions aren't that bad, but on the assignments they can just get really time consuming and just annoying. Like, honestly, I would prefer to do stats than mechanics on an assignment. So here, so rod, particle, the things you have to use to model. Magnitude, I tried to do this without a diagram, and then for the next part I realised that I did need to draw a diagram, unfortunately. You resolved upwards, found the reaction force. C being the center of mass is under the middle, or all the mass doesn't act at the middle. Now I realise that I do need to draw a diagram, and then you take moment to A to find this distance, and you get your answer. Correlation test, I'm not explaining this. Yeah, no way. Find missing values, do trapezium rule. This is it wasn't necessarily an easy assignment, it kind of was, but it wasn't necessarily easy. It's just quite, a lot of the questions can be done quite fast, and they're just quite like calculator style questions. So here, fill out your values, do trapezium rule, and again, convex, concave. So this is convex. You can kind of just see, I think, if this would be a 1 mark question, you can see that it's going to be an overestimate, because if you draw a trapezium on this, it will be an overestimate. But you have to explain it's because the curve is convex. But you can kind of like deduce that. If you don't remember which one's convex and which one's concave, or like if you don't remember exactly which one is the specific case, you can just see that if you don't remember if convex or concave is an overestimate or an underestimate, you can kind of just look at the diagram, see that it's going to be an overestimate, look at the curve and deduce that it's convex, and then you can figure it out from there. So that's why you have to remember what convex and concave curves look like, so you can deduce the stuff in the exam. Or better, just learn what it actually means. Like learn that convex is an overestimate and concave is an underestimate. So R alpha, again, comments if you need the method. Next, solve. This is a really simple question. And then 2 questions left, both being parametric integration, which is nice. So do y dx dt. As I said, y dx dt. You get this. Do partial fractions. Again, cover-up method. This is something I use to do partial fractions fast. And then you can do this and it will give you the answer. Part C, find a Cartesian equation. Well, you can find t in terms of x, and then you can substitute that into the y equation. And then domain, you can kind of just figure this out. You can either put it in your calculator or just kind of deduce it. Last question. We have a circle, so write the equation of the circle. Whenever you're doing the Cartesian equation of something with sine t and cos t in it, you just do x squared plus y squared. But here you have to rearrange it, so you get x plus 3 equals 4 times sine t, and then y minus 5 equals 4 cos t, and then you do x, so you do x plus 3 squared plus y plus minus 5 squared, and you get 16 because the sine squared and the cos squareds cancel. draw a sketch, nice. I think the things they want here is that it does intersect the y-axis, but it doesn't intersect the x-axis because the radius is 4 and the center is -3, 5. The points of intersection of the y-axis, you can just do that. And then the parametric integration, again, y dx dt, do this, turn this into, what the hell have I done here? Oh, yeah, sorry. Yeah, that doesn't make sense. So turn this into the double angles. I skipped a few steps here, but you turn the cos squared t into a double angle, like half plus half cos 2t, and then integrate that, and you get the answer. All right. Thank you guys for watching. I'll explain what will happen with the past paper, like when we switch to past papers in the next assignment video. But until then, I'll see you next time. Goodbye.